For this video, I want to show you how to calculate the ANOVA, the analysis of variance with a single factor for the resiliency scores for 3 groups. And to be able to do that, we are going to first create a new tab and double click and call this ANOVA. Then we're going back to the data. And we can do a little bit easier this time. We're going to copy the resiliency total, copy that whole column, take it to the ANOVA. Oop, did it again. Let's backtrack and go. Paste special only values. Go back to the data. Grab the age groups. Back to ANOVA and paste. And remember, now we are going to want to see these numbers in order because we want to look at the difference between 3 age groups. We want to see, is there any kind of significant difference between the resiliency scores of 18 to 25-year-olds, 26 to 35-year-olds, and 35-year-old and plus. So we have to organize them and so we can be able to get them into those 3 different categories. So highlight the row of ages and go up to sort under the data tab, under sort, smallest to largest. Again, it's going to ask you to expand the selection, and we do want to make sure that the actual resiliency scores go with that specific partner, that specific participant. So expand the selection, yes, and sort. So now we have 3 different groups. We have the 1s, the 2s, and the 3s. Let's put them, let's start over here. Let's say add a title 18 to 25, 26 through 35, and 35 plus. Now let's take these scores that go with 18 to 25, cut, paste them under here. Take the ones that go with the 2s, and the rest of them go with, well, let's not take that last one because it didn't say their age, so we'll take this group here. We'll leave that other one as an outlier because we don't know what age they were. We will have to talk about that in our findings, that there was one person who didn't give their age. But so we're only running the ANOVA on the ones who actually gave us their age. So here we have 3 different groups. I like to put these in bold. I always like to have my labels in bold. And I like my data to be relatively nice looking. There. Okay. So now let's see what it would look like if any of these 3 groups are different. So go to your data tab, go to your data analysis, and here we have 3 different ANOVAs. We are choosing the single factor because we're only looking at one variable that is affecting the, that is related to the age group, and that is resiliency scores. So is the resiliency different among these 3 groups? If we were looking at the resiliency scores and the stress scores, then we would have a 2-way ANOVA. So but we're looking at only one factor for this one. So you want to make sure you choose single factor, then click OK. So I've already done this once, practicing to make sure I got it right for you guys. So yours is going to come out like this, and it's probably going to show up a new worksheet or something. But so click in the first row. It's going to ask you for the input range, and the input is all three groups. And they are grouped by columns. If we had them going in a different direction, we'd say rows, but make sure columns is marked. We have labels in the first row. The alpha that we're looking for is the P is 0.05. That is our risk that we want to use. And then click output range because we want to see our output on the same worksheet. So I'm going to click in any box and click OK. And here you have all sorts of confusing information that I'm going to help you make some sense of. So when you report on this in your papers and you want to see is there any difference between them or not, you want to look at the p-value. I'm going to highlight that one for you. So p-value is something that we have to always look at. Is p less than 0.05? No. So there is no statistical difference between the three groups. Now you learned that we're looking for the F score. I'm going to put that as a different color. Yeah, maybe blue. So F score is what we're looking for, and we want to know, is the F score higher than the F critical? F critical is when you had to look at the degrees of freedom on the table in the back of the book to see, is our F score higher than the F critical? And you can tell right here that 0.6 is much, much lower than 3.35. Highlight that one too. Let's make that one a little bit green color. And you also need to talk about the degrees of freedom. So here are your two different degrees of freedom. Make them gray. So these are the numbers that you have to look at. Remember the degrees of freedom between groups. That is, you take three groups and you subtract 1 from them. So 3 minus 1 is 2. And you do that just to make sure that you err on the side of caution when it comes to the results. Within groups, this is where you count all the groups. You have 8 plus 5 plus 17. That gives you 29 minus the 3. So 29 gives you 30 minus the 3. So that's, which is 27. So all this, the total of this minus the three groups is your within groups degrees of freedom. So now you write this up in your paper. You write F, you have a parentheses, you have the degrees of freedom between groups, comma, between or within groups of 27 equals, then you have the F score, 0.061. I should make it to 62 because this we'll round it up a little bit because we're only going to use two numbers, comma, P equals 0.54. P equals 0.54. And when anybody reads your paper, they will then see that the F number was 0.06 and the P value was 0.5, so there is no statistical significance between the groups. So that was a very short version of what an ANOVA is, but just go make sure you look at the degrees of freedom that are reported, the F number, your F value, the F critical. You want to be able to look at that and see, is this number higher or lower than that? And my p-value shows that it is not significant at all. And that is it for this group.